Welcome to the third edition of the Connected Shopfloor Summit, where we gather people to discuss the future of manufacturing.
So thank you for the invitation, and I will start to explain a little about WEDRONE, and after the path that we are running right now, the way that we are implementing proGrow and all the system that it's being implemented in our plant. So WEDRONE, it's founded in 2020, and indeed we have the acquisition of an insolvent company named Sonafi that was performed in 2022, in the end of 2022. And since then we are maintaining the specialization in high pressure aluminum die cast. So this is our main and our business is to produce aluminum parts in the press with high pressure. And we are producing complex parts, mainly for automotive, but for other industries also. So we are in Somamed in Festa. We are approximately 200 employees, 4 melting furnaces, 23 casting cells, 39 machining centers, CNCs, and approximately 20 million euros sales in 2024. So we are expertise, like I said, in high pressure die cast, but also in CNC. So we mechanize, we make the machining of the parts, but we also have some knowledge and products with heat treatment and precision washing, and we are starting right now with adhesive bondings and some friction stir welding that is also aim that we want in the next products to be implemented. Major clients, so like I said, we are in the automotive industry, but not only, we also supply other activities and other markets like heavy duty equipments, construction, and other non-automotive clients. Skoda, Nidec, Volkswagen, Bentley, Porsche, Seat, Menenu, Malbec, Ors, and Valeo. These are a sample of all the clients that we have. The majority and the biggest ones are indeed here, but we have several ones that we are working currently, and we are searching for more business. In the end, to be the best in class in these activities, that is indeed a very huge market, we need to be a reference in the innovation, but also to strengthen our position in the automotive industry. Like I said, to expand our markets. We don't want to be only in automotive. As we know, automotive sector is up and down constantly. We are always facing troubles, stresses, and the market is not so stable like we want to be. So that's why we need to innovate and to maintain our world-class quality in our products and reliability of the service that we are presenting to our customers. So for that we intend, and this was something that I immediately when I arrived to the plant, I noticed that we were very far away from the digitalization. We have a lot of handwork process, a lot of registers that we make by hand, a lot of different operations that we saw that we can make a digitalization in our activities. So that's why we define 5 steps. We identify the goals. We define what to measure. We make where we want to make our work. We start small with pilot project, and now we are deploying and reviewing the results. So let's see each of these steps. The first one, identify the goal. So what we want, increase productivity, and we spoke a lot about productivity on the last presentations, and here. Improve the quality also, reduce costs. Paperless, again, we register a lot of our activities in paper. Increase visibility and control, and another point, engage and motivate the employees, because if we put them aware of the results in the one shot on time, then perhaps they will be more motivated for the next second, for the next minute, for the next hour to be better, if they understand what indeed they are performing on time. And we define what to measure. So what we want, OEE, so overall equipment efficiency, we want to know our productivity. Okay, OEE is more than productivity, but we want to know exactly what we are producing and why we are not producing. The time to take off, and this is very important in companies that work by shifts, because in the end, when one shift ends and the other starts, we need to know how much time we take from the last part that was produced in the previous shift until the first part that we produce on the shift after. And sometimes this time is the difference between a good productivity and a bad productivity. The downtime, of course, and the defect rates. Where we want to implement? On the melting sector, on the casting, and on machining. The three major sectors that we have on the plant. So, to understand how much work we need to do. So we have, in the furnaces, we have four. So we have four different, so I don't have the counting, it's not given, but we have four different alloys. So we have different furnaces for each alloy. And we have 21, in this moment they are already 20, sorry, because we closed one. But it was 21 high pressure die cast cells. So we have these, we have 21, like I said, total casting cells full automated, and we are speaking about cells, not about machines, because one cell means that we have the injection machine, but we have also the press, so we have two machines in the cell, and we need to control both of them. So we have also the 39 CNC machines, different brands, but the number 39. The other activities that we make also on surface treatment and the other equipments, in this moment we didn't saw the need in this moment to perform these activities there. We are more focused on the core of our plant. The finish adding, so the machining and special washing machines, where we also implement the proGrow tool. Quality system, so we also have several different activities on quality, and this is important because this is the current status. So we have the X-ray machine to check the good structure of the part without porosities. Of course, we have the after gauges to see dimensional, and also our metrology to check the part. But this is the end. This is the control that we make. But in the end of the line, we have normally person checking visually the parts. And again, manual work, registers that are made manually, and we will speak a little later how we will improve this. This is the point. So one of the aspects that we want to put is the visual control, the automatic visual control with cameras that be part of our data collection. So we will have not only the collection of the parts or the collection of the data that comes from the IoTs, from the machines, but also from different other equipments like these artificial visual cameras that will pick up the information, and we have all the information about the defects, for example, burrs or other defects that we have in the part. This is only one example where we will pick up this information, we will store it, and then we can work on them. So after we make the steps to be and to identify which tool we will use, which was the best tool to be used. So what we decide, we need to integrate the system that we choose. We need to integrate it with our RP system, because we already had an RP system. In this case, we were a little in front from what Ignacio explained. Test before full implementation. So it was for us clear that wherever it is the tool that we choose, we need to test it. We need to see that indeed it was a good tool before we put it in the rest of the plant, and with easy installation and maintenance. Because in the end, what we do not want is to put more complex our plant. It's the opposite. We need to put it less complex. And if we are putting another system that put the plant, put the shop floor even more complex, then perhaps it will be much difficult to pick up the persons and for them to show them that this is good, this is better for you, in this case for the shop floor employees, and for the plant. And maintain this process should be, and this tool should be very easy to be made. Nothing more complex. And of course, real-time data. We need immediately to know what is happening in the plant each moment, each second, each minute. So we started to select 2 suppliers, 2 different. One of them it was proGrow, and another one. And we make 2 different pilots. So we make not only with proGrow, but we made with a competitor of proGrow. And we put together working in parallel and to show us which of the systems were working, I can say better or fit more to our needs. And in the end, that's what's the results or the scale that we have these 2 solutions that was BIS testing. The support and the proactivity of the team of proGrow was amazing, was very, very, very good. Indeed, until now, we are very happy with this support that is being given. I think that is being learned between both plants. So we are also teaching proGrow about something, and you are teaching us. So it's a share of knowledge, is a partnership in the end. And of course, and we choose proGrow because the solution was the one that fits better to WEDRONE needs. After we checked both tools, after we saw both services that was being performed, not only the product but also the service, we choose proGrow. And of course, then the KPIs that we are being now checking for each level. So since the tablets that are in the shop floor until my mobile phone that I can see immediately what is happening, and I can call Julio, hey, what is happening? That's very important sometimes. So we can connect after these KPIs that are not okay, we can connect immediately with action plans and follow up with the A3 tool. So this facility, this rapid connection between failure and action plan also was very important for us. So we implement 63 EOTs until this moment. proGrow showed us to make the first one. We learned, and all the rest of them, it was internal maintenance guys that pick up and put it. Very easy. I think that we impress proGrow in this situation because we were the fastest until now. So nice work, Julio. Then we are implementing the system. So we are indeed making tailing for us. Okay, I need this, I need that. This, for example, this KPI, time to take off, was something new because in the end, there was something that we understand that was very important for us, and indeed it's possible to take out this KPI, why we cannot take it. So it was something that we also showed to proGrow, another KPI that you can show to other clients. And we are, in this moment, making the connection, the integration of our RP with MES to be connected, and in the end, to all the systems to be connected, and all the information are connected. With this, it's only one example that we have. We have a system that the persons need to go to print the label and each box, each whatever. So right now, every 25 parts is produced, one box is taken, and the label is printed immediately. So it's not needed the person go there and say, I produce 25 parts, pick up the label. No, immediately the label, after the 25 parts, that is immediately connected with the system, pick up the label and put the label. This is few seconds, but if you multiply these few seconds by thousands of parts per day or per month, then we will see a lot of potentialities that we have to make other things. So what is next? And we are speaking here a lot about EI, IA, depends what we are speaking Portuguese or English. But in the end, this is what we intend to make in the future. So right now, we are collecting data. Okay, we are collecting and collecting and collecting until the end that we should have data enough then to put a machine learning, to give this machine to understand what is the tendencies, and this is what our aim and our goal. In the near future, to be able not only to ask to the mobile phone, please give me the OE of the machine, and he will tell me the machine yesterday have the OE, wherever it is. But what we want indeed is that he predict me, taking consideration the history, taking in consideration what the machine learns with the data that we are supplying to the machine. Attention, because the tendency that you have on the last 3 days represents that on the next 5 you will go down immediately. So we can, in somehow, take actions, immediately actions, to prevent that the tendency that the machine is telling us that will happen in the future will happen. The same we are telling about the artificial vision, because that's what we want, to take out the pictures, but it's not the picture tells or will tell us this part is okay or this part is not okay. So, okay, not okay, go, no go. This is important because with this we will take out the eyes of the humans that are looking if the part is okay or not. The objective is that we also understand that exist characteristics on the parts that the picture can take out, and then with this we are able to identify tendencies on machining. For example, if the tool that we are using is passing the age that we need to substitute the tool. And with this data that is interligated with all the systems, we can, after, implement the predictive actions, not as a proactive, but a predictive, because the system, in this case, the tool that we will use as automatic intelligence will tell us exactly what will happen in the near future. And this, perhaps in terms of industry, it will be one step in front that we will take, and for sure the rest of the teams in the other companies should be made also. Okay, thank you very much.
Join our connected shop floor communities on LinkedIn and Reddit. And subscribe our channels.